Okay, this is question number 8, I believe it is, from our shadow paper for 2018, paper 2. It goes as follows. A basketball is projected just, it's worth knowing what this word actually means. It means like thrown, right? So it means some force was on it, but that force that made it go isn't there anymore. So make sure you know how that works, because in mechanics that can cause some problems sometimes. Its height above the ground is plotted against its distance, right? It reaches a maximum. It lands back on the floor 8 meters from the thrower. Assume it's a parabola. So a parabola means like sort of it has a minus x squared sort of shape to it. But with the minus x squared, maybe better to think of, if a is a positive number, maybe better to think of this. Okay. So from ground level, that's a bit weird, but okay, it is what it is. It's a bit more like somebody kicking a ball normally if it's from ground level, but if that's what it says, that's what it says. So it goes something like this. And then this is, if we kind of wanted to put some axes on it almost, yeah, this is height, I believe. Yep, height in meters. And actually I just want to make sure I get my diagram totally correct, okay? So there's my height, there's my, they're calling this D instead of X, okay? It's doing something like this. So notice that I've drawn it with a line of symmetry, and the next thing we're going to try and do is going to try and put some numbers on it. So the maximum height, so this will be the maximum height here, and this is at 3 meters. So you could write it like a coordinate if you wanted to, or you may wish to kind of just put the numbers to the side, something like this, okay, and just say, you know, oh, it's 3 meters. 8 meters from the tower. So what they're trying to do here is they're trying to say that this distance here is 8 meters, aren't they? Okay, so because of symmetry, yes, we could actually say, we could jump straight in and we could say that this here is 4, okay? So that's 0, that's 4, that's 8. So we know a coordinate, okay? We know the coordinate of sort of, what's that, 4, 3 is part of that. We can also see some coordinates such as 0, 0 or 8, 0 as well. So what we're probably going to have to do from that is find the equation. And yeah, that's actually what it is. So just one thing with this that I don't think is obvious. Now, lots of people are good at remembering to write the A. A could be a negative number. If you want to make A a positive number, you should do this, because look at the shape. It's a negative quadratic. Okay. So people are quite good at knowing this one here and substituting numbers in. But because the thing is turning here, there's actually a sort of a more useful format, which is the completed square format, which says that you can write something like this. You can write a quadratic like this. Now, this is not the same A, B, and C necessarily as we were just talking about, okay? This is just values for a completed square form. So I could say that the height is equal to this one here. I'm not going to change the X to the letter D. I'll do that at the end. And then what we do is we take these values and we sub them in. So what values could I substitute into this then? Well, I could say that the height equals A. Now, A I don't know. A means how much the quadratic's been stretched. I don't know that. That's going to be an X minus 4, isn't it? Because you take the opposite sign of that one. Yeah. And then the C is you put the actual value that is there, your turning point value. So you do something like this. Then what we would do is we would kind of expand this one out and sort of see what happens with it. So the height equals, I'd leave the A there to start with, x squared minus 8x plus 16 plus a 3, which equals ax squared minus 8ax plus 16a plus 3. Now, you might be thinking, well, that's not very helpful, but all we've actually done is we've used that coordinate, right? We haven't used other information. So we haven't, for example, introduced into our algebra yet the fact that C should be equal to 0. Well, which bit is the C bit? It's this bit here, isn't it? So x squared x, no x is on there. This bit here should be equal to 0 because it leaves from the origin. So if we just quickly do that one there, we can say that 16a plus 3 equals 0. So minus 3 over 16 is our a value. And we sort of expected a negative because of the way that we set things up. So equals minus 3 over 16 x squared. I've got to sub it into this one as well, haven't I, really? So I'm also going to change x to d because it was distance. So let's do that. Let's think about this one here. So this is going to be minus 3 over 2. Let's just check I'm happy with that. Yeah, minus 3 over 2 d. And then that's it, isn't it? Because there was no c value. So that would be my complete equation, I think. Something like that. Okay, so minus 3 over 16. There might be other ways of writing it. So sometimes you can actually write it in different ways. But that's just the way that I'm going to do it. Okay, so find a quadratic linking H and D. A hoop 2.6 meters above. So that sounds like, what does this sound like? This sounds like an H value. Is mounted on a vertical plane perpendicular to the flight. Right? Why are they saying perpendicular to the flight? I think they're just trying to get across the idea that if the ball's going higher than that, it's going to go through the hoop or something. I think that's what they're trying to say. So using your equation, find the greatest horizontal distance of the hoop from the thrower for the ball still to clear it. Right. Okay. So let's have a little think about this one. Well, we've still got an H value, which we are essentially going to plug in, I think. Yeah, let's just do that and sort of think about it along the way. So I'm going to say that 2.6, I'm going to check the units here. The units, everything is in meters, okay? So 2.6 equals minus 3 over 16 d squared minus 3 over 2d. So we found a model, now we're using the model. This is sort of the natural next step, isn't it? If I added these, everything would be positive. So 3 over 16 d squared plus 3 over 2d plus 2.6 equals 0. So I'm now going to solve this quadratic, okay? So as long as you make sure that you're setting equal to 0 and then solving with the calculator, as long as you make sure the answer sounds reasonable, you are allowed generally to do this, okay? Yes, if you did make a mistake, it is a bit of an issue because you're not making your method obvious, but you know, as long as you're careful with this and they don't say to solve it using algebra, you should be okay. So I'm going to solve this one here, and I get approximately 1.2 meters. That's one of my answers, but there's two answers, isn't there? So there's 1.2 or 6.8 meters for my d values. Now, find the greatest horizontal distance to still clear it. So it doesn't matter if we clear it on the way up or on the way down, I suppose, is kind of what's going on here. So we're going to pick the 6.8 meters and just make it clear that that's our choice. Okay. And finally, state one limitation of the model. So you can often try and pick on the context for this, or there are some stock kind of answers that you can give. So one limitation, well, air resistance is what most people like to say, and it's not covered in the question. I might, just because if you want a slightly better answer, I might say it ignores the possibility of variable resistance due to wind, which might mean path is not a true parabola. So how about something like that, right? Instead of just saying air resistance, you can talk about the idea of there being variable resistance. So it might vary because the wind might be going one moment and then it might stop or change direction or something like that. And why does it work? Well, an acceptable answer often as well is just saying that things don't actually match the shape of what's there. So I'm trying to talk about a modeling assumption and how it means that it might not follow the model that I've set up. Okay, so that would be quite a safe answer, for example.